Hello everyone. On behalf of the Victorian team at the Institute of Architects, I'd like to offer you a warm welcome to today's Lean In, Carbon and Circularity in Our Built Environment, a presentation by Ed Bond from Robert Bird Group and Lucy Marsland from Atelier 10, who will be exploring how upfront design decisions can influence building material reuse, drawing a connection between circular processes and embodied carbon. My name is Stephanie Bullock and I'm from Kozloff Architecture and sit on the Institute's Victorian Chapter Council, and it's my honour to be your host and moderator for today's Lean In session. We're joining from across the country today and we acknowledge with deep respect the traditional owners of this land. We acknowledge that it is a privilege to stand on country and walk in the footsteps of those before us. We pay our respects to elders past, present and emerging. The Lean In session is being recorded, so if you miss anything today or have to leave early, we'll be publishing this recording on the Institute's YouTube channel in the next couple of days, and we'll share that link with you in our upcoming email communications. This Lean In session enables you to ask questions of our panellists, so if you have a question or a comment, please use the Q&A box at the bottom of the screen to add yours in, and we'll go through these later in the session. Our presenters today include Ed Bond, who is a structural engineer from Robert Bird Group, who brings a holistic design philosophy to his projects. Following successful delivery across Melbourne, London and Dubai, he has developed a well-rounded approach. Ed aims to identify and advocate where the most appropriate low-carbon intervention can be made and sees the value in tracking embodied carbon throughout the design journey. Ed is joined by Lucy Marsland from Atelier 10. Trained as a structural engineer, Lucy is a passionate advocate for design excellence through thoughtful material use and creative design innovation. Lucy is leading Atelier 10's materials and embodied carbon practice, breaking down silos and facilitating holistic sustainability for communities and buildings through radical collaboration between architects, engineers and the communities that our projects serve. Today's Lean In will also discuss how to maximise material potential of existing building stock and repurposed materials, looking at the framework to facilitate the circular economy and covering topics through local and global case studies. And I'll now hand over to Ed and Lucy.
Thanks so much, Stephanie. Appreciate the Institute having us today. We're looking forward to sharing some thoughts and a bit of discussion at the end. Thanks, Ed. We could have a slide change, perhaps. Here we go. As Stephanie said, we're going to move through some classic principles of both carbon and circularity and the interaction between them, and then have a real focus on the discussion of the role of the structural engineer and the perspective. As Stephanie said, both Ed and I have a background in structural engineering, although Ed has taken his expertise much further than me. Ed will discuss material opportunities and approach in projects, and I'll conclude with some of the key lessons we've learned and thoughts to take forward. Thanks, Ed. We'll use some case studies throughout to share some of those lessons learned. Thank you, Ed. So we named our presentation Carbon and Circularity in Our Built Environment. And I always start my projects and our discussions reminding us that as designers, the biggest impact we will have in our lives is the projects that we deliver. And often we are focused on the upfront, the delivery of these projects. However, in order to have a truly impactful shift in how we think about sustainability, carbon and materials, we need to look at the whole life of our projects beyond when we maybe step away from them directly. So it's the materials phase through use and end of life, and hopefully into second, third and future lives of our projects. And when we're thinking in this whole of life way, at the basis as a life cycle assessment practitioner, what I'm thinking about is the things that enter in, the resources that enter our project's scope, and the emissions that leave, whether those are the greenhouse gas emissions or the waste or material outputs that leave our projects. And so that actually at the end of the day is what we're talking about when we think about material sustainability, is that simple flow of materials, that flow of energy into a building and seeing that building as a system and an interaction with its context. Thanks, Ed. Over the last few years in sustainability, the focus really has been energy efficiency, operations and electricity as operational carbon. But in fact, looking currently and into the future, the biggest impact on greenhouse gas emissions and the resultant global warming potential is actually the delivery and construction of buildings, which happens on day one of each project. So year on year, the delivery and construction of projects, those associated emissions are straight up into the atmosphere straight away versus the cumulative operational emissions that grow over time. And that's why, as I think structural engineers have gotten a bit more spotlight in the discussion around sustainability in the last recent years, as the industry has shifted to a more holistic and broader understanding of carbon and that elusive, ever discussed net zero or carbon neutrality. Thanks, Ed. So if we do focus on embodied carbon, what we're saying is that it's the materials in delivery upfront and then throughout the life as those materials require maintenance. They need to be looked after. They need to be replaced at the end of their service lives, and they need to be dealt with when they leave the site boundary. And so it really opens all members of a project team to contribute to this discussion, not just our energy-focused people, but actually the whole team. And we know that architects are a pivotal leader and contributor to any design team. Thanks, Ed. Now, I never skip a presentation without showing this graph, and I'm sure plenty of people have seen it before. However, I will keep showing it. This image, it comes from an international standard, EN 15978, and my dream is that we can use this language of life cycle stages as easily as we use design stages, schematic design, design development, construction. So when we talk up front, we mean A stage, product through construction, B stage being the use of the building, and C stage towards the end of life, and D beyond. So I will keep hashing those that language. I'm sure it's starting to, some people know it inside out, but I do think it's really critical that literacy of sustainability is embedded across all members of industry. Thanks, Ed. So if we apply those life cycle stages to our projects, what we see is that business as usual is a linear one. It's a linear process through materials, construction, use, and end of life. But if we move to the next slide, where we want to get to is something much more sophisticated, where reuse, recovery, the adaptation of buildings, and a circular way of thinking about these assets. We use the word assets for buildings quite often, but I don't know if we see our existing buildings always as design assets. So utilizing what we have to undertake our professional projects in a more in a way with a greater sense of regeneration and stewardship of this of our built environment. So how are we going to get there? This is what Ed's about to dive into from the perspective of a structural engineer. Those design decisions we make as a team up front, we always have to start with using less stuff. What assets do we already have? What materials do we already have? And we really will focus this conversation on that use less stuff, and we'll leave the specification and product certification discussion to others. So I'll pass over to Ed to share the structural engineering perspective on using less stuff and using the stuff we have.
Lucy, appreciated, and thanks to the RAIA for inviting me today, and Lucy. And I'll dovetail with of Lucy's sentiment. So just to hammer home Lucy's point, we've got the life cycle diagram, I think, for the third time, but it's just how the structural engineer looks at this diagram and our touch points with it. So we have the A1 to A3 phases, and that's where structural engineers as a discipline can come in and look at material selection and ways to incorporate lean design to reduce the amount of material mass. We have A4 to A5, which is a very complex phase. That's the construction stage. There's a lot of moving parts. at Robert Bird Group, we're heavily involved in this phase, and we know firsthand that the temporary support of infrastructure projects, long span roofs, more complex structures can be significant in terms of embodied carbon, and in some cases could be 30 to 40% of the permanent work. So it's not something to be ignored. We then have the operational phase and maintenance, and that's where, as a structural engineer, we come in and look at restoration and potentially a change of use. There's a bit of a buzzword at the moment, industry adaptive reuse, which obviously talks to that. And then we have at the end of life called the demolition phase. That's where we look to incorporate circularity. I think historically it's been cradle to grave, but we're looking for more of a cradle to cradle mindset, looking at our existing assets as material banks and really trying to close the loop. So the structural engineer does have a relatively large impact on our assets. It could be 50 to 60% in a building within the primary structure, embodied carbon, and if you throw in facade, that's up at over 60%. On our heavy infrastructure projects, say a station box, numbers going to be up at 80, 90%, all attributed to primary structure. So that's why I've included the graph on the right-hand side, which suggests, the influence of the structural engineer is large, and the earlier the engagement in a project life, the better. That's where we can have the most meaningful impact. On the screen, we have the 3 R's. Firstly, we want to reduce the extent of our buildings as much as possible. If we are going to introduce new elements to the building, we'll try and reuse. Reuse avoids landfill, and it also takes advantage of the spent carbon. And below that, we have recycling. Once again, avoids unnecessary waste and reduces carbon, but not to the extent of reuse. So we've run with the 3 R's, and we've got the 10 R's on the screen, so just bear with me. We have restore just near the top, so that's ongoing restoration, the maintenance I spoke about earlier, and it's extending the existing assets' life. Then have repurposing. So this is where the adaptive reuse theme could come in, and it could be vertical, horizontal extensions, strengthening of the structure, typical floor plates to enable that change of use. We loop back to reduce. So important that we firstly reduce the extent, the floor extent as much as possible. And then once we've done that, we set sensible column grids, the tighter really the better, and try and avoid unnecessary transfers. Once we've got a clear definition of the building extents, we can start refining. This is where some of the new technology that's coming through is very useful. Computational design, digital scripting can come into play, and we can refine our material further. Then got reuse and recycling, which we've spoken to. And below that, we have redefine, so we can redefine our material specifications, and that's kind of looking at low carbon options and replacements. Reinvent, which hopefully everyone can see on the screen, and that is a play to some extent on just embracing new materials that come onto the market. Definitely from a structural engineer's perspective, we have maybe historically been a bit resistant to trying these things, trying new materials because of the risk profile associated with those. We need to have faith in testing regimes and the new science that comes with it, and that can unlock emission savings. We then have reconstruct. So this is where design for disassembly comes in, and there's talk of material passport. So let's say a steel beam with a QR code which you can scan. You understand the strength of that particular element, how it was made, and it gives you confidence for the reuse. And we believe something similar could be created for the building, include load capacity of the floors. And when it comes to DFD, design for deconstruction or disassembly, there could also be information on how you safely deconstruct the building and make the most of reused elements and that carbon already spent. And then we have regenerative design. Now, potentially I should have led with that, and I'm going to come back to it, but that has circular principles at its heart, and you can see here we need to be working towards a closed loop. Continuing then with the theme, we have a brownfield site here, and it's got an existing asset on it. In this particular case, you can see Battersea Power Station, which is a famous adaptive reuse project. But really, starting point is just looking after our buildings, applying TLC, and if we have regular maintenance regimes, could be every couple of years, we can prolong the life of our asset indefinitely. And ultimately that reduces the planetary harm, the carbon spend, and it's the best overall outcome. More often than not, we're not doing that, and we are maybe waiting till the end of a particular cycle, could be a tenancy cycle, or waiting till the end of the 50 years, in buildings, or over 100 years in infrastructure. And then we're trying to restore the materials. That results in more additional materials being required, and we might need to strengthen. In some cases, we need to move the existing assets. That's where the reuse comes into play, and that reduces the planetary impact. So recycle then falls underneath that, and lastly, and up until recently, it's been our default position that's demolish and landfill. And from what I understand, there's some estimates that the construction industry is responsible for 80% of global landfill. It's clearly not sustainable. It's affecting our ecosystems, and it's something that we need to move away from. We're not always going to have, though, an existing asset to work with and a previous carbon spend. So this next example looks at a greenfield site, or it could be a brownfield site with no existing asset on it. There may be an opportunity with a site strip to reuse excavated materials. And other than that, we can look at nearby sites and reuse materials, and recycle materials. And then we move on to an adoption of materials with hopefully lower energy intensity. And then if we kind of look at the business as usual case, things like cement, which is formed from clinker, we have high energy intensity, and with that, without a decarbonised grid, we have high carbon. I mentioned earlier about regenerative design, and here are some headlines from the Institution of Structural Engineers. We've got firstly designing for place, so understanding the local context in terms of society, the people there, respecting nature, working around it, and also construction techniques. We have circularity and reuse, so me and Lucy have just been talking about the benefits of that. We have material choices, choosing materials that may be available locally and dovetail well with local construction practices. And we have knowledge transfer. So I feel privileged to be on the call today to share my thoughts. And we ideally need to scale this down and up and have as many conversations as possible. Just jump onto a case study here. This is a temporary office for Sydney Metro. Fabrication, embedded circular principles in terms of understanding the fabrication process. Stock lengths were available to reduce the amount of fabrication and waste, and embedding elements of DFD, which I spoke about earlier, designed for disassembly, so bolted connections, and CLT panels, floor panels that can be removed at a later date when the building's repurposed for its second life, and potentially more lives beyond that too. So at this point, probably just in terms of some metrics, give you an idea of the benefits of recycling and reusing. We take steel here, hot rolled steel. We can see the Australian default position. This is the neighbours data that's just come out. Results in a large embodied carbon dump on the planet, and that's linked mainly to the fossil fuels used in the basic oxygen furnace. It's coal, and you can see it's significantly more here than the European average, and that's mainly down to the infrastructure that's available within Europe, and some of the processes that have been in play for a longer period of time. But within Europe, there's a more decarbonised grid, and there's also greater access to electric arc furnaces, which take advantage of that. You can see as we kind of drop down and we just look at purely EAF steel, and the carbon drop off is substantial, and even more so with 100% renewables, which is hopefully where we're heading to. But at the bottom there, you have reused steel, and you can see the carbon is a fraction of where we started. So you can see why we need to be pushing for this as much as possible in the industry. So I guess at this point, people on the call may be asking, why don't we just specify reused steel on every project? Well, fortunately, this comes down to supply, and this is where we, on the screen, we've got global supply and production of hot rolled steel, and you can see the majority of that is primary steel, with maybe 10% coming from recycled steel. Now, that's definitely going to improve over the years to come, and the secondary or scrap steel may make up 40%, 40 to 50% of our total steel production, but we're still going to need to produce primary steel. And there are some developments. DRI is a process that is under R&D at the moment, but in terms of it being scaled out, it's likely a couple of decades away. So we've also got to be aware of the challenges that come with changing the infrastructure, and also the cost as well that comes with electric arc furnace. It's a good example. BlueScope at the moment relining their basic oxygen furnace, and relining alone is $1 billion. So the steel industry and some of the industries trying to tweak and adjust that infrastructure needs ideally investment at potentially government level. Another material that's been spoken about a lot in sustainability circles is mass timber. That can sequester carbon. There's no doubt, similar to steel, it can really help us move towards this net zero goal that we've set ourselves by 2050. But as everyone's aware, there are some things that are out of control when it comes to actually harvesting sustainable timber. One recent example were the bushfires we experienced in Australia. You can see there's two projections here. The one on the right is more positive in terms of extra timber that we're going to produce over the next 20 years, and maybe it's an extra 40%. But you'll see from the next graph that due to the explosion, you could say, in our built environment, we need a lot of additional floor area, and reused materials and maybe mass timber on its own isn't necessarily going to get us there. And on the left-hand side, you've got 24 possible scenarios for population growth in Australia, and likelihood is, within the next 80 years, there's going to be a tripling of the population, something close to it. So we need to work with potentially materials which are more abundant. This is a graph which going back to regenerative design and understanding local practices, shows that the lion's share of construction materials within Australia, concrete. And this is where we can celebrate some of the advances from the Australian construction industry. And it comes to concrete, post-tension concrete, Australia is seen as a world leader, and our designs are very efficient. So it's something that we can definitely work with going forward when we're designing and thinking about materials. And if we are going to think of concrete, as I'm sure a lot of people on the call do on their projects, how do we reduce the impact of that materials? Everyone's probably familiar with cement replacement, fly ash, which comes from coal, and blast furnace slag, which is from the steel industry. We also have geopolymer cement replacements. We can recycle steel, and we are actually doing that within Australia. A lot of the reinforcement comes from electric arc furnaces, has a lower footprint, and takes advantage of a decarbonised grid. And there are future replacements for cement, because in the next 10, 15 years' time, coal power stations are going to get phased out. So fly ash will be less available. So we need to start thinking about replacements. One of those is calcined clay, which is being used already in Europe, and there's studies underway within Victoria, things like limestone fines. So how do we calculate our improved impact on the planet and lowering our emissions? We need to really start measuring carbon on our projects, and a lot of projects these days are undertaken using 3D models like Revit. We have access to very valuable data. So this is output from software Robert Bird Group has developed, called Magpie, where we take out different components, attribute weights and volumes to them, and then calculate carbon, and gives us the insight to really reduce our kind of understanding of where the carbon sits, and then focus our attention on drilling down to what's going on. And rather than trying to tackle everything, we're more focused with our efforts as we try and reduce cost as well as carbon. And you can see here I've got a high-rise residential building. The majority of the carbon is going to sit in the floors and the stability system. With a low-rise building, the carbon is mainly going to be sat in the floors. Something to add here: when we're looking at carbon, we feel it's always useful to have a range. There's an argument that it could be seen, because it's still relatively emerging, carbon calculations, that they're a bit of a dark art. So we like to give a range that could be with the different data that's on the market, say EPIC versus neighbours. In this case, we've looked at a range of national averages versus EPDs. Going back to what I mentioned earlier on taking out components and understanding their carbon and material impact. Here, there's a study on floors and column grids on the perimeter for an office tower. And if you reduce the grid, as it's quite clearly understood now in the industry, you can reduce the carbon. So that's kind of clear with the output here. But we're also using material quantities such as concrete and reinforcement as a means to reflect cost savings, as well as linking that directly to carbon, and that can be a single source of truth when it comes to carbon data, which can vary in some cases wildly. Here we have a case of adaptive reuse, and got the starting point, which is an existing hotel that wants to be adapted for a retail conversion. So here we're trying to maximize the building envelope. So we're introducing extra floors. Because we're reducing the clear head height, we've had to take out folds within the slab and replace existing floors and associated carbon and get the service to work harder. We started with this, but the team actually challenged that approach and kind of asked the question of, what if we try to minimize our intervention and add floor where it's needed, but retain the existing? And one of the conclusions we've come to is when it comes to improved floor to ceiling height, it actually improves the value of the space. So it kind of opens up the retail conversion to high-end luxury where there's greater returns. Obviously reduces the capital costs, and ultimately it lowers emissions. It's a challenge back at this point to the industry, when we're involved in those conversations, to maybe let our clients know that could be a different path to go down, where we look to really minimize work and changes to the structure, and get the most out of that carbon that's already been invested. Yeah, I'm just kind of reiterating the point that we can minimize, if we minimize our floor areas, we minimize upfront capital cost, and we can reduce our footprint. And see, kind of running here is some of the digital tools that are at our disposal when it comes to lowering embodied carbon by refining column layouts, which could embed architectural constraints to really slim down our slabs as much as possible. Just flick back up. There's an example here of one of the projects we're working on, large infrastructure project, Northeast Link, and through incorporating digital scripts and optimization rules, we're able to significantly reduce the amount of reinforcement, and also we're able to visualize that through 3D parametric output to understand where wastage may have been occurring and take that out. Here we have an adaptive reuse example. We used historic wharf down in Docklands in Melbourne, tested the historic timber piles, justified they had spare capacity. We then selected a lightweight material in mass timber, which also helped to make more of an inviting space for the public. So I'm getting close to the end of my section, but I think this is something I'm just throwing out to everyone on the call. If we can make a substantial impact and difference in those early stages, is there an opportunity for us to extend that period? And yes, that comes at higher fees, but if we can reduce the amount of material volume associated with it, there's direct value from a cost perspective, but obviously we end up with better planetary outcomes as well. So it's something we could maybe consider thinking about with our clients, and this next diagram ties in with that. And it's really bringing everyone to the table from project inception, all disciplines, understanding everyone's kind of point of view, and just working to that common goal, which can be low cost as well as low carbon. Just to finish on, in a finite world, the planet has a capacity which, when it comes to taking on more carbon, and I'm just wondering, at the moment we're measuring carbon on a kilograms of CO2 equivalent per square meter. That's useful for comparing across projects, but when we have these large infrastructure projects, there's a big dump, regionally, nationally, and globally from that. So should we be looking at the total carbon? And then likewise, when it comes to occupancy, could be residential tower, could be just a single dwelling. Do we want to be thinking about caps on embodied carbon? One example, Australia has one of the largest house sizes averages, in the world. So is that something that we need to think about when it comes to the reduce that I touched on? So at this point, I'll hand back to Lucy.
Thanks so much, Ed. It's wonderful to dive deeply into the many components of the structural design and how that does interface and impact the architecture and building as a whole. So I think it's clear from what Ed has described and all those nuances that that this is a wholesale change in the way that we think, going from the 3 R's to the 10 R's. I think lays down a challenge, not just for structural engineers, not just for architects, but for building owners and the whole design team to serve our communities. We had a lovely project up in New South Wales that really embodies that wholesale regenerative outlook with a circularity focus, and it's in fact a building at the tip. So what better place to showcase the undervalued opportunity of reusing materials, and what always excites me about this project with Terroir as the lead architects is the way that circularity and materiality is embedded in the narrative of this place. It's in a place for education, for gathering and exploring curiosity, and showcasing materiality really it changes the fabric of the experience of architecture, which really excites me and gives a nice contrast to the engineering systems and magic numbers that Ed and I could spend all day looking at, but when we zoom out, that way that materiality can change the narrative of a building is a pretty magic part of the whole story and keeps me coming to work every day. Thanks, Ed. Next slide if I can. So Ed talked about different materials, timber, reuse, structural steel, concrete with its opportunities to include fly ash, slag, other cement replacements. But actually, I know from what I took away is that there is no silver bullet. We need to meet every project where they are. We need to drive every project to challenge the brief, to explore and be curious, and to look on site, but also to those other adjacent sites, to the context and the community of a project and the supply chains, and being place-based. So what works in Europe doesn't necessarily work in Australia, and we're really committed to being place-based on every project, and meeting people where they are. And so, yeah, the big thing, there is no silver bullet. I think anyone that sells you a silver bullet need to challenge that and instead build this literacy, build our understanding of our context, both our supply chain and our places, and that's the way our projects move forward, with nuance and a holistic approach to circularity and managing our carbon, investing our carbon wisely on every project. And the way that's going to get done, as I see it, is as Ed said, it's about challenging the way we program and model our project delivery. Is a little bit of extra time at concept design is the biggest opportunity to influence the outcome, actually at a very a relatively lesser cost overall for the project. Having a integrated design delivery where exploration is supported and facilitated, as shown in this diagram, is the way that we get the engineering team, the design team, and all the supporting design consultants to explore, to challenge and innovate, and then come together to around a table where we can share those innovations, share our responsibility to our communities, and over time refine our design. And in this way, it's more time up front, but it avoids what can be experienced on projects, particularly in this sort of current environment that we're all living in, of getting to tender and the cost plan being too high and sending us back to day one, or at least at the start of design development. So it does challenge the way our projects classically get delivered, but I actually also think that there's lots of ways this is not that radical. We see it on infrastructure projects, having a project office, having a joint venture. There are examples where we can carry over, and I think integrated design is a key part of delivering these very aspirational, ambitious but critically necessary outcomes around sustainability. And my last slide, thanks, Ed. So if that all comes together, I think we can shift as designers from focusing on just design and getting our building up off the ground to a position of stewardship, where these are communities we serve. To be a designer is to serve a community, as far as I see, and to be stewards of the assets, the community assets and the design assets that are around us, identifying ways that we can leave a legacy as designers, but it's a legacy of service. It's a long life of our assets, and it's one where their future second, third, infinite number of lives can be enabled. And it's just our time that we have that we can contribute to this process, bring our own each personal skills, whether those are the structural engineering skills, the skills of architecture, or for me, that life cycle assessment and sustainability, sustainable design thinking. So I hope that between Ed and I, we've given you some nuanced insights and some zoomed out reflections on what carbon and circularity's interactions are, what the opportunities are for this place where we are in Australia, and how our projects model, our program and our teams can really enable that to improve, invest our carbon, invest our materials, and consider the planet on every project that we work on. So we will open for questions. We've given ourselves 15 minutes and we love a question, so please don't hesitate to submit one via the Q&A tab, or any comments as well, and Stephanie will pick some up for Ed and I to respond to.
Thank you so much, Lucy and Ed, for that fantastic presentation. And I think many people would find it incredibly refreshing to hear from two structural engineers that are so passionate about this. And I suppose that leads to I guess, a question of mine. Often as architects, we're responsible for engaging the structural engineers on a project. How do we, I guess, make sure that they have the capability, but also the scope to undertake the types of analysis and options testing that you're talking about?
That comes down to the scope. I mean, if I'm honest, Stephanie, I think at the moment I'm seeing the industries going in the opposite direction where we're kind of de-scoping. We're chasing, definitely in the Melbourne market, we're chasing a lower fee, which is less scope. And I really don't think anybody wins, definitely when it comes to carbon and circularity. So I do think collectively we can as an architect could request that being in the scope as a bare minimum, and if we can explain to our clients the value of that, then and I think there could be a movement in the right direction. So and likewise, we can also lean on architects as well. If we're in that position of kind of bringing architects on board and going back to what Lucy was just presenting there, it's just collaboration, isn't it? It's I'm obviously quite biased as a structural engineer, but with the influence we have, but I guess there's operational carbon as well, which is still significant. The building surveyors, the building services engineers need to be part of that. So it's really bringing everyone to the table as early as possible.
Can I add in there? I was inspired to become a sustainability consultant because of this idea of integrated design. And I think the way that collaboration happens is at the person-to-person scale. And so more opportunities to connect at the person-to-person is a really exciting one. And that's when often, some of those most iconic projects come together. Like I remember learning about, classic architecture and engineer partnerships, Renzo Piano and Peter Rice at or Sydney Opera House with Ove Arup and Jorn. There's magic stories of architects and engineers, friendships and partnerships, and I think there's opportunities for the Institute, and we saw the Institute of Structural Engineers connecting and collaborating, so those friendships and those connections at the personal level set us up for really successful project outcomes.
Great, thank you. I just want to pick up on something that both of you mentioned, that the ideal way to include this type of early collaboration and options testing is to have more time in concept design. I mean, I think most architects would say that would be great, but realistically for a lot of us, particularly if you're working on larger scale projects and also with particular government institutions as well, it's simply not practical. As the principal design consultant, if we ask for more time, we probably won't actually win the job. What other strategies are there, apart from asking for more time, to still pursue some of these ideas and testing and benchmarking?
Yeah, I do personally. I think we are time poor, but if that's not available, that there are more. I think more scrums, more of that collaboration we spoke about. I think I think that's one of the things that maybe just very regular workshops through those early phases. You're talking kind of maybe two a week, and to get the best possible outcome. I mean, I touched on there are some digital kind of advancements that have happened which can accelerate through it. I mean, it just depends how much time you've got. I personally think the value of that maybe kind of kicks in the detailed design phase, where you can kind of set up the scripting. But it's definitely possible with computational design to take advantage of that as well, where we're trying to accelerate as much as possible. But I think it's just talking as much as possible, probably what I'd say.
Understanding the client's brief as an outcome. What are they trying to achieve actually at the end of the day? It probably helps some of those options around challenging the brief of the whether it's the column grid spacing or the program. If we can make sure we have a really clear understanding of the outcome, the vision the client has, I think that opens up the conversation to shake up, the expected design pathway that would be strictly in line with, I guess, the brief up front.
Great, thank you. We've got a very specific question that's come through in relation to your sort of average single dwelling unit in Australia in terms of what would be the approximate embodied carbon footprint from the A1 to A5 stages. It's very specific and technical, so feel free to say you don't know off the top of your head.
I have actually looked at some data fairly recently. That it's obviously a lot. It's smaller. I think it might be at like 200 kilograms per square meter, something of that order. It's going back to what we said before, but it's a bit dangerous sometimes using that data because it varies so much, across a project. And one of the points I was kind of making is there could be quite a high-end luxury residential development, which actually scores pretty well on the per square meter, but it has 200% the area of the average house, and the average house probably is on a global scale is, I think it's the highest in the world in Australia. So it gives you there's definitely improvements I'd suggest that need to be made, and just challenging the brief all the way through, yeah, from the get-go.
All right, I think we've almost come to the end of the questions. One final one from me, I guess. As architects, we also don't always get to pick the structural engineers that we work with, depending on the procurement model. Sometimes they're appointed directly and report directly to the project manager or the client. You mentioned before, Ed, the difficulty of de-scoping, and I think that's a challenge across a whole range of disciplines. If we are working with a structural engineer who perhaps hasn't allowed for any of this in their scope or fee, or perhaps hasn't explored these things before, how do we bring them on the journey? You two are obviously all in terms of, you're really committed, but how do we get people to see the value of this, to engage with us? Are there resources? Any advice in terms of how do we bring the whole consultant team along?
I think it is that conversation back to the client. Sorry, Lucy, I just jumped in. Setting it out, setting out what you're planning to achieve, on the project from the start. There's some good guides out there. I think this from the UK, the Institution of Structural Engineers was touched on. You could definitely go to that website if they're not familiar with it. There's some good starting points on how you calculate carbon, examples. So that could be one way. And we're obviously happy at Robert Bird Group to come in and give you some advice, if you need it. So,
I can add
avenues.
I can add some other references, a bit of a reading list for people, both for architects and for structural engineers. There's a recent World Green Building Council collaboration with Grimshaw. I'm not sure if there's anyone from Grimshaw attending today, but the Monaro platform is a really valuable tool that I find very helpful in laying out a map, a pathway through project development of what activities or just conversations or calculations to do at what time, and that can help just anchor you and what should we be doing in concept design. What can we do before a bill of quantities is available or a BIM model is available? So I'd really endorse the Monaro app that is released earlier this year. And I'd also say, as Ed says, that the targets and the vision and the aspiration of the project is the number one thing to guide the team into what's important. So projects where, for example, Green Star is a commitment, that might be from a planning perspective, so it's really a must-have. It's not a nice-to-have. We're really shifting from sustainability being a nice-to-have to actually aligning with the client's commitments at a corporate level or at a planning level. And there's actually a lovely Green Building Council guide to reductions in upfront carbon specifically. But what I like about it is that it frames the discussion by discipline or by actor, by participant. So what is a developer's considerations? What's a structural engineer's considerations? And then my last reading list item would be to encourage structural engineers to engage with the Institute of Structural Engineering, which does really great courses, and for anyone in the design team, architects, engineers, to engage with MECLA, which both Ed and I are contributors to, as a way to build literacy. I think that literacy needs to come first. If we don't share a language, if we don't understand the principles of life cycle of a building, it's very hard for these interesting design optimizations or design big moves to occur. So there's a bit of a reading list if I can jump in and get some more CPD points through some of those industry platforms.
Thanks, Lucy. And we've had one more excellent question, which leads on from that. So as architects, as part of our code of conduct, we have national competency standards as well that requires us to consider environmental sustainability and life cycle assessment. Is there a similar requirement for structural engineers?
Yeah, we just kind of tag in underneath that. I mean, Lucy just touched on the Green Star process, so we do feed in, and it's definitely changing. You know, there's been some recent changes in the Green Star sustainability rating tool, and it's placing a much larger demand on the structural engineers, reducing embodied carbon, a pretty tight target. So that is coming through actually as soon as I think you're involved with Green Star, which isn't every building, but so we have a few of them in the office at the moment. Things are starting to change here in the industry. There's definitely been a movement in the past couple of years, and I think in terms of what we're expected to do, probably nationally in the industry, you know, people are talking about maybe the next 3 or 4 years that's going to be mandated by the NCC. So this is coming. Like everyone needs to kind of just jump on board as soon as possible. Like it's maybe not mandated, but the sooner we start doing it, obviously the better for the planet. But it's going to be legislated very soon.
Fantastic. Thanks, Ed. And of course, this session itself is being recorded and will be released. You'll get a notification as to when that's released, and also new lean-ins as well by subscribing to the Australian Institute of Architects YouTube channel, YouTube at Oz Architects. Thank you so much, Ed and Lucy, for that fantastic presentation. And thank you, everybody, for joining us today.
Definitely.
Thanks. Bye.